This tutorial will show you how to run Way ANOVA in SPSS. Here is our data. We have the rating scores of a special flavor of ice cream from three age groups, 5-year-olds, 8-year-olds, and 12-year-olds. We want to see if their ratings are statistically significant. So first, let's get the data into the program. Only the rating scores. Going to copy. And I want to get the data paste onto here. Because we have rating scores from 15 children. So we want to set up the data a little bit differently here. The way we set up the data for Way ANOVA is quite similar to how we set up data for independent samples t-test. We'll need to move this. Okay, I'm going to go a cut, and then move here. I'm also going to move this here, because our ratings are from 15 children, so we have actually 15 independent rating scores. So we want to set up our data this way, and that means these ratings are from 15 children. And then we are going to create a new variable, and that will tell which rating is from which age group. For example, the first 5 are from the 5-year-olds group. So we want to we can write 5-year-olds in this column, but the program works better with numbers. So I'm going to code the 5-year-olds as our ones. First 5 are from the 5-year-olds, and the next 5 are from 80-year-olds. I'm going to code the 80-year-olds my 2s. And the last group is from 12-year-olds, and that will be our 3s. And then after that, we don't need this variable. I'm going to clear this. And then go to variable view. In this window, I'm going to name the first variable rating. Our next variable is our group variable. In the group variable, we coded the 3 age groups with different codes. Now we need to label the codes so that we know which codes refers to which age group. And that will be in the values here. Click on this. I'm going to code ones. That's our code 1 will be 5-year-olds. Our 2s will be our 8-year-olds. And the 3s are 12-year-olds. And then, okay. And I want to reduce the decimals because we only have whole numbers. And then you go back to your data view. You see now we have 2 variables with names, variable names here. And then we have the independent variable, which is the group variable, and the dependent variable, which is the rating scores. Now we are ready to run Way ANOVA. To run the analysis, go to Analyze and Compare Means Way ANOVA. And then this window comes up. I'm going to add in a dependent list box. I'm going to drag the ratings into that box. So if you have other dependent variables you want to compare the 3 age groups on, you certainly can put them all in this box. And the group, drag that into factor. That's the independent variable. And we have 3 buttons here: contrasts, post hoc, and options. The first 2 buttons are relating to the group comparison after the Way ANOVA test. So after the test, if we have specific hypothesis as to which groups we want to compare, then we use planned contrast, the contrast. That's the button we use here. If we don't have a specific hypothesis to guide the comparisons following the F-test, then we're going to use post hoc procedures. And basically, we just want to compare every pair, and it's called pairwise comparisons. And we are going to see how we're going to do the post hoc procedure in this tutorial. And let's click on post hoc procedures. So the post hoc procedures, we have a bunch of procedures available, and these are grouped by equal variances assumed or equal variances not assumed. That means if we can assume that the three groups have similar variances, then we can use procedures from the top panel. If we cannot assume equal variances, then we need to use procedures here. Because now we are not sure, so it will be better to pick a procedure from equal variances not assumed. And what's recommended is Games-Howell procedure. If equal variances can be assumed, and because our group has similar size, 5 actually from each group, then we can pick Tukey's procedure. And because we only have 3 groups, which we don't have very many groups to compare, then we also can use Bonferonni procedure. If we have other group, like our groups have different size, then we might use different procedures, and use the slide to guide your analysis as to which procedure to use for your situation. And I'm going to continue. In the options window, we want descriptive statistics. We want the equal variances test called homogeneity variance test. Because we have small sample size, we also will pick these. These are F tests. If the assumption of homogeneity of variances, this assumption is violated, then we'll need to look at F test from these procedures. Way ANOVA can also produce a simple plot that shows the means for each group. And continue, and OK. And then we'll come to our output. Let's move it a little bit. Okay, what's happening? It's coming up. Okay, good. So first we have the, let's move it a little bit. The first table is the descriptives table. I think here you want to see that the sample size, mean standard deviation for each group, and also has a total for the total group. You want to look at the averages and also standard deviations here. You see the standard deviation for 5-year-olds and 8-year-olds are the same, while 12-year-olds standard deviations are larger. So you want to see that if these 3 groups have similar variances, and this test will tell you whether the 3 groups have similar variances. And the Levin's test is to test now that 3 groups from populations that have the same variances. If you look at the sigma value, which is greater than 0.05, so we cannot reject it now, and we conclude that the groups have similar variances. Even though 12-year-olds has higher standard deviation, we cannot reject it now here. So then that would be good to read the F test from the ANOVA table. And in the ANOVA table, we want to look at still the sigma value here. So the sigma value is less than 0.05. And so we reject it now that the groups have from populations have similar ratings. So we reject it now and conclude that the ratings are significantly different. If the variances test comes out significant and our group has a smaller sample size, then we want to read F results from this table. And for now, yeah, we'll ignore this table. And then we'll move on to our post hoc tests. Because we asked the ANOVA to give us to do the pairwise comparisons. So we asked for Tukey procedure and Bonferonni, and also Games-Howell. Because our groups have similar variances, then we don't need Games-Howell procedure. We just read from Tukey's and Bonferonni. So if you look at the Tukey's procedure, you see that here 5-year-olds compared with 8-year-olds and 12-year-olds. And then you look at the mean differences here. What's come out significant, we have a star here. And also if you look at the sigma value, it's less than 0.05. So the differences between the groups is 5-year-olds and 12-year-olds. If you look at the confidence interval here, this interval does not include 0, so means their means are different. And then if you look at the Bonferonni procedure, it's the same story. Yeah, it's 5-year-olds and 12-years significant different. And the program also gives a simple plot that just shows the averages of these average rating from the these 3 age groups. You see that 12 years much lower than the other groups, but the test tells the significance is between the 5-year-olds and 12-year-olds. That's the end of this tutorial. Thank you for watching.